All right, Algebra 2, we are on the second day of 3.6, so we're calling it 3.6B. We are going to start off, wow, I spelled actual wrong right here, that's really good. We are going to start off with finding the complex and actual zeros of a polynomial. That's what we ended yesterday with, so hopefully this is a little refresher. So we're going to start with y equals 2x cubed plus 5x squared minus 38x minus 95. So first we need to find our possible zeros before we can find our actual zeros. Our constant in this equation is going to be negative 95, and our leading coefficient is 2. So the factors of negative 95 would be 1, 5, 19, and 95. And for our leading coefficient, that'd be 1 and 2. Just a reminder, to find these possible zeros, it is a fraction with the constant factors over the leading coefficient factors. So we're going to always use 1 on the bottom for these first four, and then we'll move on to 2 after that, just so we have everything covered. So 1 divided by 1 is 1, 5 divided by 1 is 5, 19 divided by 1 is 19, 95 divided by 1 is 95. Again, we have plus or minus for all of these. And then we're going to move on to 2 on the bottom of our fraction. So 1 divided by 2, 5 divided by 2, 19 halves, and 95 halves. And we have all 16 possible zeros right here. So in order to find if these are actual zeros or not, we are going to test them with synthetic division. It can take a while if we don't guess it right away, right? So I always just start with positive 1 and then move on from there. These numbers in our synthetic division come from the coefficients of our polynomial right here. So 2, 5, negative 38, and negative 95. And we're going to start by dropping down our first number. And then we're multiplying the number in the box to this number. 1 times 2, we write it up here, that's 2. We're combining these, so they're both positive, so we're adding them. 5 plus 2 is 7. Now we multiply again. 1 times 7 is 7. Combine them, that's negative 31. 1 times negative 31 is negative 31. If we combine these, I didn't even bother doing the math. I just knew that it wasn't a 0, right? They weren't opposite numbers right here. So if this isn't a 0, 1 isn't a 0. Let's do the same thing with negative 1. Drop it down, multiply. Drop down, multiply. Drop down, multiply. Not the opposite numbers, so not a 0. So negative 1 isn't a 0. Got to keep trying. This is where it can take a little while. I'm going to save you some time of listening to my notes, and we're going to skip ahead to negative 5 over 2. So we're still using the same coefficients. Drop it down, multiply, drop it down, multiply, drop it down, multiply. We have opposite numbers. 95 plus, or negative 95 plus 95 is 0. Therefore, negative 5 over 2 is a 0. So when we factor this, we're going to pull out x minus negative 5 over 2. And when we subtract a negative, we have 2 minus signs back to back. That's a positive. Another way to think about it, it's just going to be x and then the opposite number of your 0. So x plus 5 over 2. And then how do we figure out what goes on the rest of the polynomial? We use these coefficients right here. We have a constant, an x, and an x squared. So 2x squared minus 38. There's not 3 terms in here, so typically we could use like the quadratic formula, but here we only have 2 terms, so let's find out what these 2 numbers have in common. They both have a 2 in common, so let's pull out a 2. So we still have our first term, x plus 5 over 2. We're factoring out a 2, and then if we pull out a 2 here, we just have x squared left over. If we pull out a 2 here, we have negative 19 left over. And from here, we can find our zeros. So this 2 is eventually going to come in front. Let's just focus on where there's x's. So we're going to set these terms equal to 0. So we have x plus 5 over 2 equals 0. We're going to solve for x, and x equals negative 5 over 2. That's 0, number 1. It's also our same number that we found that was 0 here. So you don't necessarily have to. I was just showing you how we figured it out. And then we're going to take this quantity right here, so x squared minus 19 equals 0. Let's add 19 to both sides, and then we're going to square root to get rid of this square. And when we square root something, we always have 2 answers, plus and minus. So x is plus or minus the square root of 19. here is the second and third zero. We knew that we were going to have 3 zeros because our original equation had a cube. The highest power was a 3, so that means we're going to have 3 roots. And then in order to factor the whole polynomial, let's go back here. We factored out that 2, so let's put that right at the front. And then we had x plus 5 over 2, x plus 5 over 2. And then our other zeros were plus or minus the square root of 19. So for the positive square root of 19, it's going to be x minus the square root of 19. And then for the negative, it's going to be x minus negative square root of 19, which is a leave change chain. So it's actually x plus the square root of 19. Another way to think about it, you just flip the sign in front of it, right? So negative 5 over 2 is a 0. So we flip that sign to a plus, and then same thing on these two. Last example is a little quicker. And again, like this stuff it's just really different to think about. We've never really talked about anything like this before in any of their classes. So please do reach out for questions. When like Savas gives us an I or a square root in our given roots, we need to include their positive and negative root as well. So for example, they're going to give us the roots 2 and 3 minus I. We can just use just this one, just this 2, but then since we have an I right here, we have to also add the other root that they didn't list of 3 plus I. So we just have to switch that sign right in front of the I or right in front of the square root. And then in order to expand this and write the polynomial, it's going to be y equals parentheses x minus, and then whatever this root is, so x minus 2. And I highlighted all of these in blue because these were our roots. Our second one is going to be parentheses x minus, and then the whole thing, 3 minus I for this one. And then the last one, x minus, and then the whole thing, 3 plus I. So parentheses are important here because now we're going to distribute these negatives. So our first one is just x minus 2. Then our next one was x minus 3 plus I, because a negative times a negative is a positive. And then right here we have x minus 3 and minus a positive I, so that's another minus I. So they only gave us 2 roots. We found a hidden third one, right? And then we had 3 quantities right here, 3 terms. If you do have questions, shoot me an email.